Laura, you there?
Yep, I'm there here.
Awesome. Nice. Wait, what is it? It's all there in here.
Where am I?
So, Adam, do you listen to Heavyweight with Jonathan Goldstein?
No, I don't.
Do you listen to podcasts much? I'm not sure how. Do you?
Not much. Listen to the Enron one recently and the Elizabeth Holmes one before that, but not that much.
So I guess I listen to like doing dishes or driving the kids around or whatever. But so Heavyweight with Jonathan Goldstein, Gimlet podcast, outstanding podcast where he goes to people and kind of solves problems that they have had deep in their past, often a reconciliation with someone from their past. It's very, very good. Very well done. But every episode of Heavyweight starts with him calling his friend Jackie, and Jackie usually hanging up on him. And listening to all of I thank you so much for uploading all of the past Twitter Spaces to Spotify, to syndicating them as a podcast.
Oh yeah.
So I've been listening to a bunch of them, just kind of like as I've been driving around, and I realized that we have our own like Jackie. We start every episode complaining about Twitter Spaces. Basically, that's how more or less. I mean, complaining is actually overly. We actually shouldn't give ourselves a hard time because we are more observing things that are busted about Twitter Spaces.
Yeah. I was wondering where this was going.
Meandering journey was going. Yeah, that's where we are.
I don't know if you noticed listening. I was reminded of my own in-joke listening back to some of the, now that it's in podcast form, that I went through about 10 episodes in a row where I cut it to start with you saying, all right. And there are about 10 episodes that if you advance through them quickly, you just get Brian saying all right as the first word.
Now, this is not, our dedicated listeners should know, your first act of editing prowess.
Okay. Tell me more.
I feel it's Pat Gelsinger and Andy Jassy, right?
Yes. The Pat Gelsinger, Andy Jassy supercut of them disagreeing on whether it's on premises or on premise.
But they're not actually disagreeing with it. Just one says it one way, the other says it the other way.
That's right. Back and forth. Yes. I thought you might have meant I did one cleanup episode in this show, and I won't mention which one, and then a different cleanup where I added you saying Happy Valentine's Day, Bridget.
Yes.
But the edit was so clean that I think that it may not be observable.
I will pass that on to her. But she will immediately smell a rat. Although actually, as recently as this morning, though, you are actually sending the three of us like embarrassing photos from our shared past. So I don't know if it's gonna see through that one.
There we go.
So, but then Laura is here. Laura, we thank you so much for joining us. And Laura, I was trying to remember because I feel like we talked about the first vulnerability here, but then I realized that the dates don't quite line up because
I thought we did, or at least I definitely remember talking about it.
Yeah,
somewhat.
Right. I think so too. I don't know where we did. We did, I think, at some point, but I think we started doing the Twitter Space kind of after you had the big disclosure a year ago. So to be clear, we are talking about another LPC55 vulnerability. Although for people who follow the company closely, we're not talking about another LPC55 vulnerability. It did occur to me that wait a minute, did Laura find another vulnerability since like a week and a half ago? The answer to that is not yet. But Laura, I wondered if you wanted to maybe start with a little bit just a backstory of the vulnerability you found in now December of 2020 is when you found the first vulnerability, right?
Right. So, backing up a little bit, when we talk about the LPC55, this is a chip from NXP that we selected to use for our hardware root of trust. As part of Oxide's shtick about building a new server is that we want to be able to have this hardware root of trust to be able to measure what's on the system. And after doing a lot of deliberation, we decided the LPC55 was the best choice out there. And then we started the process of trying to bring up the chip. And while, it's certainly easy to be able to like get initial code running on it, trying to do some of the more advanced features that we actually want to be able to use from it, proving to be kind of difficult to use, and also sometimes partially related to, struggling with some of the documentation. And I went through a series of problems trying to get this going, which resulted in me bricking a whole bunch of chips. And I actually, when I visited, I visited the office a few weeks ago, Rick actually gave me a stack of those chips I bricked, so they're sitting on my desk right now. I need to do some sort of art project with them to commemorate those.
I think you need to like adorn an actual physical brick with them, because I mean there was a stack. I feel like there were like 5 or 6.
Yeah, there were quite another of them. I kind of want to put them in resin or epoxy or something, but
And so you should explain to folks like how it was possible, like the level of software you were developing and why it was even possible. What we mean by bricking the chip, first of all.
Yeah. So I mean, okay. Backing up a little bit more is that I used to be a kernel maintainer, and sometimes one thing I would always tell people is that it's generally okay to experiment with your kernel, because it's pretty hard to actually script your system, assuming you're trying things pretty carefully. I mean, short of like putting random failures in your file system, there's a pretty good chance that if you try and do a kernel and it panics, it turns out, panics for the most part are recoverable. But for what we're doing with these LPC55 microcontrollers, they had some settings that are designed to be programmed, and it turns out, because what it is that when the chip boots up, it goes through the boot ROM, and which is where I eventually found the vulnerability, and I'll get to. But as part of going through the boot ROM, it will check various settings, and it turned out that it's possible to get those settings incorrect, and as a result, have the chip not be able to boot up and not be able to fix it in a meaningful way.
Yeah, so when we say bricked, I mean we mean like it's lost at sea. There's basically, as far as we are aware, no way to recover those things.
Yeah, so I mean, I ended up with a stack of stuff right there, and then I think it was actually one of my coworkers, Cliff, had actually got the idea, hey, we could read out the ROM, because NXP hadn't like read protected it, like unlike other chips out there. So what if we just started to disassemble it to try and see what was going on? So he pointed me to that, and I ended up picking that up and going to try and take a look at it a little bit closer, just so if I can try to identify code paths where exactly I might have screwed things up. And I did eventually find some places where I think I screwed things up. But as I started taking things a little bit closer, it was actually very interesting to try and figure out what this thing was doing. And I spent a lot of time cross checking the addresses that were being referenced with those against the manuals. And I found this one set of addresses that were not actually mentioned in the manual, but they were definitely within the hardware space. And then I ended up cross-checking that against a spreadsheet that was else. So
you should describe the spreadsheet, because the spreadsheet was a surprise. It was a total surprise to me. I mean, maybe it wasn't a surprise to you.
Yeah, I mean, okay, so it was one of these things just looking at a little bit more closely. But so we had this spreadsheet, and it eventually referenced this region called ROM patcher, and I was able to cross-check where this part of the flash was being accessed, and I was able to put that 2 and 2 together. And using exactly seeing what the code was doing in the ROM and looking at the disassembly, I was able to get a good idea about what this ROM patch was doing. So that was really cool. Then of course, I got, the brain cells connecting and decided, okay, what else can we do with this? I mean, is that the first thought when you see something like a ROM patch, you must assume, okay, there's a good reason to have a ROM patch. I mean, I think that should be emphasized, that like the thing about a ROM is that, of course, if it's true mask ROM, you can't change it. But if there's bugs in your ROM, you're going to need some way to fix that. And so that's the idea of what this ROM patcher is supposed to do. So there are good reasons you want this. But the catches and where we ran into problems was that it was possible to modify the ROM patches after boot up. So what it is that we discovered that it was possible to do this, and it allowed you to potentially violate various security boundaries, both in the privilege, non-privilege area, and more importantly, I think for our eventual purposes, was violating the boundaries between trust zone.
Well, yeah, and so a couple of really interesting points to that I just want to go back and emphasize. One, and I don't know if I quite realized this, kind of the origin story of the origin stories of going in to disassemble the ROM, because to make up for the lack of documentation.
So some documentation, but like I found some of it kind of confusing and hard to follow. And I mean, I really see this as an example of about I know I have a lot of respect for documentation writers, and I think they are certainly doing their very best. But I mean, I see this as an example of a company that is, not chosen to put documentation at the forefront of their strategy, for example.
That is definitely true. And then the spreadsheet, as I recall, was contained in the PDF,
Yes,
right?
it was attached to a PDF, which I had never seen before, and a lot of people actually realized you could do that.
Yeah, I did not realize you could do that either. Like, what can you just have like? And then of course, people who know PDFs well are like, "Oh my god, you've got no! It's like a virtual machine. You can have it's not it's not a document. It's a program that you're running on your computer." You're like, okay. So it was definitely eye opening. And then so you're getting into the Flash patcher, discovering that the ROM patcher, which I think you did a very good job of articulating why these things need to exist. That actually it's when you're developing software that is is immutable. It's a little scary, and you have to have some way of kind of fixing defects, certainly. So then, but Laura, I think it's also worth emphasizing that NXP made, I would say, a classic error in that as you were disclosing to them the fact that this thing was not locked down, had not been secured, there's kind of a sense where they were challenging you to escalate the privilege. There's they kind of minimized it, honestly.
I mean, I think we were definitely not happy with the way that escalation ended up happening. I think just simply because I think, especially from our perspective, there was I think Rick referred to it as a lack of creativity involved about what we were trying to do. I gave a proof of concept about what it can do, and they kind of came back and said, okay, maybe you can do something with this, but they took it at face value as opposed to trying to think through all the implications about what you could actually do with this. And then I think that was at that point, I think it was really Rick went back and, came up with the idea about demonstrating this using their own trusted firmware. And then we engaged in, I think, a game of assembly code golf to figure out exactly how we could get a proof of concept in a useful way.
And that they were more receptive to. I think they were still. I think we were a little bit dismayed about what we felt was an unnecessary delay in the process. I also feel, Laura, I don't know what your take is on this, but I feel the work that you were doing is so intensely creative in terms of understanding how you can basically take this thing out of its design center. Challenging the creativity of someone so creative that is not a path to success. I think I do not think that's dangerous.
Yeah, and I mean, I think this is ultimately comes down to thinking about threat modeling. And I mean, I'm grateful for colleagues like Rick who have really taught me all about how to approach troubles like this, and think about exactly what problems are you solving when you're trying to do things like this, and can you imagine and just come up with all the different ways that you can come up with problems like this. So I think I think we've definitely learned how to be very creative in our approaches for things.
And then, so with this vulnerability, there is a CVE. I was shocked, Laura. I don't know if you were shocked by that. I was floored to learn that NXP's disposition to CVEs was that it was basically an opt-in system, and they didn't feel like opting in. And I had never. I mean, that was definitely never my. I thought that CVEs. I mean, clearly it's not like there's not regulatory compliance issues, but I thought everyone had the attitude of like, no, this is a common vulnerability database, and everybody needs to share this for the good of the industry. I don't know, Laura, were you surprised at all by their disposition on that?
I was a little bit of surprise, but I would also say you could probably do an entire episode talking about like CVE security processes, just because I think it's important to remember is that when we think about what is the purpose of CVEs in terms of trying to get things out there. I mean, I think the CVE discussion was more of an example of the bigger picture problem, which is a lack of transparency in terms of actually getting this information out there. I mean, all of its flaws, the CVE process is a great way to be able to get that information actually out there.
Yeah, I had the same reaction to you, Brian, which I didn't think it was an sort of optional. People could say, Shark could say, not us. And I almost see it as a way of sort of burying some of these details, in that it's such a, because everyone uses it, it's like it's sort of hidden within other disclosures. But I guess they didn't view it that way.
And I can understand where they're coming from. I mean, it's like, it doesn't feel good to have a vulnerability in something that you've really tried hard on, having been there. And I get that kind of that temptation, I guess. It's so that you have to You have to listen to the better angels of your nature for sure on that. And it's kind of unfortunate they didn't.
And especially for a part like this, right? Like,
Yeah.
especially for a part like this where, I mean, maybe it cuts both ways on this, but one where, you know, trust and security are part of the they're on the tin.
Well, and I don't know, and maybe I guess I don't do this anymore, but I would look at the CVEs to get a sense for what has been discovered in a part. And if you look at NXP, they're like, oh, there have been 4 CVEs in the history of NXP. Like, wow, that's amazing. It's like, well, actually, it's not that amazing as it turns out, because they have vulnerabilities, just not disclosing them. So that was, and then, Laura, you remember them saying like, well, we can create like, if you want, we can create a CVE. Like, yes, we want.
Yeah. I mean, I think this is also a case, though, about, and when we talk about the weaknesses of CVEs are very software focused. And so when we're dealing with a hardware company, it's one of these things that it's like, okay, what exactly does a, CVE for hardware actually mean? I think when we go back to, everyone's favorite Spectre and Meltdown, this is another case where, especially in terms of trying to do this, the concept of signing CVEs for Spectre and Meltdown didn't always make a lot of sense because it wasn't tracking things in a useful manner. So I can sort of see exactly how a hardware company may not approach things in a different manner. But again, I think this is going back to my previous point. Like, this is more just related to lack of transparency. I mean, if they didn't want to do CVEs in their particular manner, maybe that would be okay. Is that if they had other ways of making sure they can get things out there?
That's right. And so on that, so during this whole process, one of the things that we were asking them for, I mean, just to your point, Laura, we've been asking them for more transparency for everybody, for their customers. And in particular, we were asking them to, and still would ask them, and would ask all vendors to make the source code to the boot ROM available so we can see it. That way, Laura doesn't have to go reverse engineer it to figure out how to use this thing. And we think it'd be very beneficial for the source code to be out there. And NXP does not agree. And so they told us under NDA, they told us and I'm going to read their quote. Or Laura, do you want to read their quote? Or I don't want to take away any out loud reading from you.
I don't have Andy with me, so if you want to do a dramatic reading,
if you want to violate the NDA, knock yourself out, boss.
Well, no, that's right. Oh, damn it! I thought I was getting some fingers on the revolver. No. Okay, I'll explain that in a second. So yeah, they shared this to us under NDA. They say, even though we are not believers of security by obscurity, keeping the interest of our wide customer base, the product-specific ROM code is not open to external parties except the NXP-approved Common Criteria certified test labs for vulnerability reviews. And so, like, even though, like, you just explained security through, like, you're not, even though we are not believers in security by obscurity, we believe in security by obscurity. So we asked them, okay, fine, you're not going to release the boot ROM. This statement, can we issue this statement publicly? And they released us from our NDA for that statement. So there you go, Adam.
There you go. All right, good.
So they don't seem, I mean, like, we kind of think this is like, well, you're kind of showing your bare ass here, but okay, fine. That's, you know what, there you go. So, and then Laura wrote a terrific blog entry on this. This is a year plus ago. So Laura, when did that blog entry come out? They came out, it was almost a year ago, 11 months ago. And Laura, what was the kind of the reaction to that? Was that, was this the first big vulnerability that you've discovered? I mean, what would kind of walk us through what it was like to discover this and then to get it out there publicly?
I mean, it was, kind of pretty intense to be able to actually get it out there. I had done some sort of informal, mostly bug hunting, never anything that was rose to this type of level before.
And then it should be said that you ended up you and Rick did a DEF CON talk.
Yes.
Which was terrific. We can link the video. That was, how did you feel? Because DEF CON was not in person. Did you miss doing the in-person thing? Or I personally I'm so scared to take an electronic device to DEF CON.
Yeah, I'm still disappointed that it was not actually feasible to try and go in person. I had been to DEF CON once well over 10 years ago, and it was a good time. And I mean, I'd love the chance to maybe get a chance to go again. But I did get the speaker badge and everything. So
okay, that's pretty cool. But you still feel like you've got some unsettled business in that due to the pandemic we couldn't be there in person. I would have liked to be there in person. So then I think we fast forward to December. We're continuing to build our product, and walk us through how you found this vulnerability.
So okay, so even after I found the vulnerability in this ROM, I sort of continued to try and poke at other various parts of the ROM that were there, mostly because, we talk about creativity. It was also like a problem that was sort of sitting there, staring me in the face, like I want to try and figure this out. I mean, just because what exactly all the parts of this that actually did. And I mean, I eventually kept trying to convince myself that this was actually good for the product. So, I think one of the areas I started to look at was the in-system programming ISP mode, which is designed to be able to program things in a secure manner. And one of the features of this ISP mode is to be able to take a signed update image to be able to apply that when the chip is in fully locked down secure mode. And there's documentation out there for the format itself, but as far as what the ROM was actually doing was processing, I was curious exactly how this thing actually was. And I will admit I kind of had a motivation of looking at this because I didn't actually want to sit down and write our own processor. But I really kind of got curious about exactly how well things were bounds checked in terms of parts of this format, just because it's a fairly complicated format. And again, I'd like to say, if you think about the higher level problem about what this is trying to solve, like a lot of it actually, how you get a format like this actually does make a lot of sense, is that microcontrollers are very memory constrained. And so the way this format is designed, it's broken up into 16-byte chunks. So the idea is that you don't have to have a lot of memory required to be able to stage the update. And things need to be encrypted because, okay, fine, you can do that. It's sort of that if you think about the firmware update problem and you follow the logical conclusion, I can easily see how you get something like this.
And this is the SB2 format.
Correct.
And you had asked on Twitter, I don't know, did you get an answer? What is the history of this format? Because it's just kind of like, where does it come from?
So I asked on this because I was looking around at this just because I'm really curious about it, just because I think as far back as reference, it seemed to come out of Sigmatel, which to the best of my knowledge seemed to be a company that was involved in making audio chips. And if you can see the parts of this that are referenced in the format itself, just because it uses a couple of magic numbers like SGTL, which I think is short for Sigmatel, and SMTP, which is the name of one of the chips. So I think this format has existed. It's also interesting to look at this as how exactly this got to NXP, and I think the answer is that Sigmatel was acquired by Freescale, and then Freescale acquired by NXP.
This is awesome. Laura, can I ask tactically, when you're disassembling this, when you're looking at the different capabilities of this ROM, what kind of tooling are you using to understand this?
So I should probably, give a caveat that, like, I am by no means a reverse engineering expert. I mostly just use Ghidra, which is an open source tool that's available. And what it does is it provides a dump of the assembly and then a disassembly, back into C code side by side. And the disassembly generally does a very good job, but it's certainly not perfect. So you're sometimes left, scratching your head trying to figure out exactly what makes sense. Then it's up to me to be able to annotate the variables and the function names to be able to identify what exactly this thing is doing.
I see. So it takes the assembly, turns it into pretend C code, and then you get to edit it to try to make sense of it.
Yeah.
I would love to, because I just seeing what you've done with Ghidra, I have not really had the occasion to really use it in anger. I would love to. Why? I mean, Adam, it's so neat what it allows you to do, and it allows you to save this state and share it with other people too. So Laura could work on it, and then Laura, correct me if I'm wrong, but it allowed you to kind of annotate the stuff and share it with someone else who might be able to offer their perspective.
Yeah, and I think it's certainly designed in a manner such that it's supposed to be used for teams who are reverse engineering, and it's possible to have it be a shared project. But I mean, I just have it as an individual project, but you can certainly do things in a much more powerful way. And again, I'm not an expert in reverse engineering by any means. This is Ghidra's one such tool. I know there are other tools out there that are also do similar things.
But it's really neat. Okay, so then you pull it up in Ghidra, and actually, can I ask you a question that I feel like, what does SB2 stand for?
I'm honestly not sure. I'm pretty sure the 2 stands for the second generation because you talk about a version 2 format. I'm not completely sure what the SB stands for, and I'd love to have an answer for that.
Right, some carcass of a company that was devoured, like it's like the plankton that was devoured by the Sigmatel or what have you. So you start reverse engineering this, and are you is your disposition like we want to understand if this is a format? I guess you said this earlier that like, hey, if this is a format that's going to save us a lot of work, we'll use it if it makes sense.
Yeah, and I think that was our original motivation because when I was writing up what exactly we were going to do for this, is that I talked about the trade-offs. And I think after we found this other vulnerability, we had gone back and forth about whether we wanted to use this. And I pointed out the advantages about if it's there. And I think our initial plan was that, okay, fine, we'll use this as a backup. And possibly a worst case scenario, or be able to do things. That's case, it should be fine. We think we can isolate the ROM patch enough that this shouldn't be an issue.
And so how shortly after getting into this code with Ghidra do you realize that, oh my goodness, the bounds checking, maybe not so much?
I had sort of, again, this is sort of like a long-term project. I would sort of work on it here and there. Honestly, probably sometimes working on the ROM more when I should have been doing other things. I know this is a bad thing. My boss.
Not at all. Not at all. No, this is actually, so I think that that's actually an extremely important point. Actually, is that because I think it is really, I found this of a lot of the things that we have done that have been most important, honestly, have often had this kind of origin where someone was just kind of like was following their instincts or doing something that was like related but somewhat ancillary. So I actually think that's really important that you felt the freedom to go, and you should, because it's what you found is really, really important.
Brian, I'm very glad to hear you say this. Is that, I have this, I have not yet disassembled the USB stack. So
right. You are now sharing a Google Doc with me that actually I would like you to repeat that. Yeah, exactly. That's great. No, I think this stuff's great. I think that this stuff, I think all of this stuff that I think that people so often make the mistake of being driven by a particular deadline or what have you, and driving past a wisp of smoke, or not exploring an issue that they should. And then as it turns out, that deadline gets blown because you should have explored that issue and discovered that there was something really substantial there. So I'm really, really glad that you explored this. And plenty of these explorations, I'm sure, did not bear fruit. But boy, this one sure did. So
yeah,
yeah, go ahead.
I started to take a look at this. I was kind of I was honestly not expecting to find anything. I was hoping to be able to, say I took a look at this and be able to report back, at our hubris huddle that says, okay, I took a look about this. It seems they have pretty good bounds checking and something, yada, yada, just have it, kind of be an afterthought. But
okay, so can I ask you your disposition in this? Because I feel like there is a change in disposition when you know that code is wrong. Do you know what I mean, Adam? Like where you like as a code reviewer, I try to summon that same feeling that I have when I'm like, I've debugged a problem and I have debugged the problem down to this function. I know this function has a bug. Like the way I read code when I feel when I have that disposition is so different than the way I read code. Like it's a total. And Laura, when you go in, what is your disposition? Like, I want to understand this, or is your disposition like, no, I am convinced that there's a problem in here?
So I initially just started just wanting to understand exactly how the parsing actually worked, and just be able to try and understand this, just because it's ended up being a fairly large state machine. And state machines are one of these things that I think is, kind of like the bread and butter of a programmer in terms of having something to implement, in terms of trying to see exactly how this thing works. But I was also curious about what exactly it had to do in terms of trying to process all these things and how exactly it checked all things, just because the format is somewhat complex. And there are a lot of and I was exactly how it worked, especially some of the quirks about how it does some of the encryption and other things like that. So I think I started out with just genuine curiosity, and then got the brain cells or ideas going, and says, I wonder how well exactly they're bounds checking. I think I just went in with a curiosity, just in terms of just trying to figure out exactly, looking at this as if I were a code review, says, okay, the input I'm giving is coming from me. What exactly can I do exactly if I, set these fields to be larger or smaller?
And do you think that the presence of the earlier vulnerability changed your disposition at all?
It's possible that I think it probably did have some impact. I mean, I think especially just because in terms of other things, you're just trying to take a look about trying to figure out what it is. And I mean, honestly, in sort of counterintuitive, I think if NXP had released the ROM source code, I probably would not have spent all this time trying to look at it, just because auditing auditing sources, far less.
Oh, that's awesome. It would have been too boring to read the actual source code. But it was much more of an adventure to grovel through the disassembly.
Yes. So I mean, but I think the fact that it was there and sort of staring me in the face in terms of what exactly is this thing doing.
That's fantastic. I love it. And with regard to the bounds checking here, if I read the blog post correctly, it wasn't that they did it wrong; it's that they didn't do it for this block. Was that right?
So it's that's a good way of putting it. So for those who haven't read the blog post, the way this vulnerability ended up working is that as I mentioned, this is an update format that's designed to be processed in 16-byte chunks. And what it is that the blocks are numbered, from 0 on to the end in terms of identifying where certain pieces would be. So there was one piece of the header was supposed to be where exactly you could find the set of key blobs for keys for being able to do the decryption. And what it turns out, what they were bounds checking on in terms of being able to do some copying was that they were not checking is that if we had gone up to the header size, instead you were talking about when you reach a specific number, and you ended up with a classic buffer overflow that way.
Yeah, wow. That must have been amazing for that light to go to. When you kind of made that realization, were you thinking like, okay, I must be missing something somewhere. It can't be. There's got to be this code's.
So I mean, I'd probably say when I was backing up a few more steps about how this works. So this bug ended up being pretty bad just because it was designed to be used in ISP mode, and ISP mode is supposed to be pretty restricted in terms of what you're supposed to be able to do. You're not supposed to be able to run arbitrary code, but I was initially doing some testing because the same parser code is used to be able to do this from in-application programming, and I was stepping through it with a debugger to be able to see what it is and be able to get a better idea. And I mean, I really knew I was actually onto something when I was stepping through it. I could see it was writing outside the bounds of the buffer I was there, and then I mean, once that happened, I knew I could.
Wow.
It was just a matter of, could I actually turn it into something useful, or was I just reporting that there was an overflow?
Okay. And then, so then I would assume that like that is a real inflection point where you're like, okay, now we go from curiosity to now the tenor of my curiosity has shifted.
Blood is in the water.
Exactly. Well, I'm trying not to necessarily make Laura sound like an apex predator, but at some point you must feel like, yes, blood is in the water.
I mean, I'm not going to lie. I'm forever going to be chasing the high of, getting code execution. Like it's a pretty good feeling.
It's a good, yeah. I mean, it is definitely right. I mean, it's a good feeling just to watch. I feel like I'm watching like so it must be extraordinary to realize that like, wait a minute. This vulnerability, I don't think we're exaggerating. This vulnerability is I think much more serious than and not to downplay the severity of the vulnerability you found last year at all, but this one is really, really bad news.
Yeah, I think what it is in particular with this one, as I mentioned, the update format here is both encrypted and signed, so it's designed to come in, but this bug actually comes in before the signature checking actually happens, which makes it pretty bad. When I started to take a look, I was kind of expecting to see exactly, I might have found something after the signature had been checked, which would have been kind of bad, but less bad, just because that would have meant that you would have actually had to sign an image before you could actually do something useful, which is, again, you get to a different level of threat model there. But I mean, the fact that basically you could send any set of bytes and be able to get this, then
it's bad news. And especially because if you have a secure microcontroller in your architecture, in your device, it's probably because you have something worth securing. I mean, so the kind of the presence of this, right?
Yeah, but I feel like it's also worth saying, we're very doom and gloom, but I think it's also worth establishing, like, what things is that this vulnerability did not give us? I mean, this vulnerability lets you give us execution, but not fully persistent execution if you have things locked down and fully signed. With their what that means is that you would, if you did a reboot, you'd have to be able to do this again. If you're using their security NXP security mechanisms, things are still protected there. You can't fully change part of the key store or other things like that. You can't actually do the signature. You still have the signature checking. But one thing I would say that that was pretty bad was being able to extract the device secret, which was related to the dice feature.
Yeah, this is one of these where like, okay, this is like not my domain of expertise, but like extracting the device secret, that seems bad.
Yeah, and what it is that DICE is a feature that comes from the Trusted Computing Group that's designed to be able to give an identity used for attestation. So the idea is that it's based on HMAC to be able to do a calculation based on what code is in there. So the idea is that you can get an identifier that can be used as a secure key. And the idea is that you're supposed to have a device secret that's secret, so that nobody else can use that to be able to eventually be able to derive the key. And what it is with this vulnerability, you're actually able to extract that before things get locked down. And I mean, this is one of these things that actually it sounds bad, but it's kind of a fallout about when exactly this bug had happened. Because what it is because the device secret is used in conjunction with the image that's on the flash, you need to have those two tied together. So because ISP doesn't actually have you booting into an image yet, it's necessarily going to be unflashed yet. So I think the fact that I was able to extract it didn't necessarily mean there was a weakness necessarily in how that was protected. It was much more just that I was able to do this before you had an image there.
Right. Okay, because you were able to basically inject, but this is before we actually got the image. So you discovered this on like right before Christmas.
Yes.
And so I recall us. Did we get on a call? I mean, I definitely recall you discovering this. The thing I thought was really interesting is, in addition to contacting NXP, because I think unlike, well, I guess like the previous vulnerability too, we had a real concern about what is the impact on our product here. Like this actually could be really devastating if we can't use an update functionality at all.
Yeah, and I think that was why once we got done trying to do the vulnerability reporting, I think I was worked with Rick and others to try and do a write-up about what exactly this would mean for a product in terms of trying to evaluate our options in terms of trying to actually get a product out there. Just because again, it turns out this is all nifty stuff, but we can't actually sell the pride in terms of finding vulnerabilities. So
right.
Well. Right.
I'm not sure we can't. We can try. Yeah, exactly. But no, that's true. We can't sell DEF CON talks. It turns out they give those videos out for free. So we actually need to. But I thought that. So we, as folks probably know, we had these requests for discussions, RFDs, and so Laura, your go-to was to write an RFD about this new vulnerability and our level of exposure.
Yeah, and I think honestly, I was doing it half in to organize my thoughts as well in terms of trying to figure things out and hopefully be able to give a summary. I mean, mostly because I think to be able to point back to it later and says, okay, why exactly do we make this decision in terms of being able to just lay out all the trade-offs? And I think that was where I think I stood up, just pointing out, it says, okay, this is not affected, this is affected, in terms of being able to say it out for everyone, and then being able to figure out what exactly were we likely to be able to do about this.
And I think that this RFP is great because it is so helpful to, and it sounds like it was helpful for you as well to kind of like, okay, what are the actual paths here? Certainly one of the paths, and one of the paths that we definitely got asked about, Laura, I don't know if people asked you about this directly as well, but they're like, people are like, hey, how many vulnerabilities are you going to have to find in this thing before you start using something else? Like, are you in a bad relationship with this part? And
that was
yeah.
We had seriously considered in terms of trying to figure out if it was out there. But again, I think what it is that the set of features we were looking for in a part, it was actually very hard to try and find something that we wanted that was out there. And so I think we sort of went around in circles is that there wasn't anything that was out there that I think that was actually available we could purchase, because that's the key. I think there were a couple of things that always sounded promising, but I think even when we were starting to search for the part, I think back in, when I joined in early 2020, before we started to getting into major chip shortages, I think there were certain things that were still unobtainium, and now, even more of these things are even more unobtainium. So I think it was sort of doing a careful calculation about what exactly are we supposed to do at this point. Is that these things just aren't out there, and we have to ship something.
Well, and even then, what would we look for? A part that had not had vulnerabilities found in it yet, right? Like, because when we were evaluating the NXP55, these these vulnerabilities were unknown, and it hadn't been Laura Abboted yet.
Exactly. This is your always eat Jack in the Box. This is after the after the E. coli outbreak in California, Jack in the Box. So
this is something I thought in my 20s. True. I would not eat a Jack in the Box.
That is an unverifiable claim. I don't think that's right at all. I think that is. Talk about challenging creativity. You are now challenging me to put you in a situation where you will not eat a Jack in the Box. So good luck with that. Because you know what, Jack in the Box is actually pretty good. Like that's what I gotta say. Jack in the Box, not that bad.
So Laura. But when building a product around this part, or where this is a key component, it's not that like no one vulnerability is necessarily debilitating, or it doesn't preclude it, or, make the whole product insecure.
Right. And I think that this again goes back to our threat model in terms of trying to figure out what exactly it means in terms of trying to mitigate this. Because if we think about, when we go back to the ROM patcher, that was a pretty bad one. But then it also turns out we did the analysis is that we could narrow down about under what circumstances we could we would actually be vulnerable to this, and we were able to sit down and discuss it and decide, okay, if we take these precautions and set things up like this, we feel we've isolated enough to avoid any potential issue. And I think we did the same thing with this one as well, especially in terms of evaluating what the update mechanism is that this issue was limited to being able to use the update mechanism. So I think the safest thing, I think, is to be, if you can't get a fixed part, is just to not use that update mechanism.
Yeah, and then the stakes are higher too for us in terms of timing. We are, Laura found this. The timing was, in one hand, great. She found it after we'd done our EBT1, but as we're working on our second EBT rev, and it's like, if we're not going to use the LPC55, like, we need to make that decision tonight. There was urgency to it. And Laura, I think the exact line you had in the RFD was that the LPC55 S69 is the winner in a sea of mediocre candidates. And it is, like, I think it's important for people to realize that this is not, and actually, to be fair to the domain, this is a hard problem. Secure silicon is really, 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 really hard. And there are so many vectors, and you're going to put this thing in someone's physical hands and then expect it to keep secrets. And that is super hard, I think.
It really is. And I think in terms of especially trying to figure out the set of features we actually wanted to be able to do this is a somewhat narrow. I'm not going to claim it's a super narrowly scoped, but I think also, at Oxide, we were kind of picky about what things are out there. And I think especially in terms of trying to look at what exactly we wanted to do for things. I'm not sure if people saw when it was going around the person, I'm blanking on his name, who broke the hardware crypto wallet. That's an example about something we try and evaluate about what exactly we're trying to do. So
yeah, and I think that the other thing that Adam, you're talking about, like, the vulnerabilities not found in other parts. I think for us, like, to contemplate something else, it has to be there has to be something very tangible that we're getting, not just, oh, by the way, we don't think there are vulnerabilities in this other part, because I think NXP has taught us that we never to trust again. What I would want is something that would get our attention, I feel, and this is not for our first product because we're kind of locked and loaded. But Laura, I'd love to hear your take on this. But I feel like a truly open top to bottom, open boot ROM, open ROM product would be interesting. It would need to be all open though.
Something open would actually absolutely be a great start, or at least have a good way for us to be able to review the source code and be able to see exactly what's on that. And I mean, I think it would also be interesting to look at and see exactly if we can have a smaller footprint for the ROM. I think it was actually Cliff who was unhappy even before when we were first selecting the chip that it seemed to have this boot ROM, just because I think he preferred just to be able to have it chips just boot up and run exactly your own code, which I can understand exactly why he does that. Especially now we see exactly why Cliff had that opinion.
Totally. Okay, so expand on that. Actually, I haven't actually gotten this particular rant from Cliff. So his view is that the boot ROM is completely unnecessary, effectively.
I don't think I don't want to put words in Cliff's mouth here, but I mean I think I've heard him before say he generally preferred especially earlier generation chips. It seems like that would, when you would boot up, it would literally just boot to your own code, and you would be able to do things that way. But again, I think we talk about things like a secure processor. It turns out that you sort of end up with the bootstrapping problem about, okay, if anyone can try and get in and to be able to program code just because that's what you need to do if you don't have a boot ROM, then that means anybody can get in, you or your nefarious hacker. So
it's also a real pain that you want to be able to change the software on this thing. You don't want to actually just ship a ROM mask. Like, we actually want to ship software to this. You want to change the software. And that's the origin of a lot of this challenge, is our ability. I mean, that was the origin of with the Flash ROM patcher and with the SP2 issue. It's like, ultimately, it boils down to upgrading the software securely, or fixing it securely is really, really challenging.
Yes.
So, okay, so now we are evaluating. It's late December. You, I think, are wondering, if I recall, kind of out loud, if you're like, oh wow, this is like, I guess this is like a winter solstice activity for me. This is what I do for the solstice.
I forget if it was you who noted that, or I who noted that, who exactly noted that. But yeah, this kind of ended up coming like right before Christmas, I will admit, because there was a little bit of Oxide downtime, so I decided to take advantage of that to try and what I was going to call play around with this a little bit more. So
right, okay, so we it's that time of the year. We celebrate the solstice by finding a vulnerability. You disclose this to NXP, and it's probably worth saying that NXP's reaction this time is different.
Yes, and I think NXP was very receptive to this. I think, especially, I think we were able to show them a proof of concept. And I mean, I would probably say this entire thing, I think, was a lesson for Oxide as well, into how to do vulnerability disclosure as well. As, I mean, I think we try and be good citizens in terms of how we communicate, but I think also making sure you have a clear proof of concept and explain things as clearly as possible. I mean, I do think, NXP is full of engineers who are working very hard, but I think, if I think about it, for example, is that if we were to find a vulnerability, someone else were to find a vulnerability in Oxide code, I would appreciate having a well-written write-up in terms of showing exactly where things are. So I think in terms of trying to figure out exactly where things were. So
we try to be complete as possible. You had very thorough, it was very hard to argue with it too. I mean, it's like, and I mean, to their credit, like, they didn't, right? I mean, they accepted that this was a vulnerability, because I think we also were feeling we had negotiated on timeline with the first vulnerability. And I feel, Laura, I seem to recall us thinking, like, this time we really are not going to negotiate on timeline. It's really important to us.
Yeah, I think there were some things that I think we reflected based on our previous time. But I think this time, fortunately, I think we didn't end up having to go there. I think they were very receptive in terms of trying to get it out there and keeping us up to date and everything like that. I mean, and I'd like to believe, we were trying helpful and trying to guide them into ultimately do the right thing, because what we see this just going to mean.
Oh,
sorry.
Did Laura not break up for you, Adam?
No. I think that's just
Twitter Spaces. No.
It's okay. Hang on, Brian. Hang on.
My God.
Stay together.
It's okay, Brian.
It's not okay at all. But so sorry, Laura. I missed what you said.
I mean, I'm just pointing out that things were going much better with NXP this time, and I mean, I'm very glad that things, I think, did go well, just because I think I want to see them continuing to try and be more proactive about security, and I'd like to see all companies out there do that in terms of being able to get disclosures out there and make sure they're protecting not just their customers, but also everybody out there who uses them.
Laura, this is a really good point, because I think we are, and hopefully we have never come across as just kind of like beating up on NXP, because we actually want all these companies to do better. We want them to actually do better, not just by us, but by their customers, by the industry, and we want them to improve. So I think I would like to believe that our previous experience with NXP made them better this time. I mean, it felt like they took us more seriously, or they certainly didn't challenge the severity of this. And I thought they also did a better job of not minimizing it and getting ahead of it and then disclosing it to their own customers. Because on this one, like, you got some customers that are potentially very, very exposed.
Yeah, and I mean, it sounded like that they did a much better job about trying to get this out there. So I think that was definitely something we are, happy. We were very happy to see.
Very happy to see. Yeah.
No, Brian, imagining the perspective of our future customers, at some point on our website, we're going to have some description about our root of trust and our security posture. And presumably we're just going to embrace these vulnerabilities and describe how, the attack vectors and how it's not applicable, but continue in that transparency.
Absolutely. I mean, in terms of like a vulnerability in Oxide software, for example.
No, what I mean is, like, this NXP part, which is part of the Oxide rack, has these vulnerabilities that appear on our blog. So we're going to tell people, what the implications are or are not for
That's
them.
right. Yeah. I mean, I think that absolutely. And I think that we all of us at the company have been on the kind of the receiving end of vendors not always being transparent, not always being forthright. And I think, we want to be the example we want to see in the world. So I think also, even when we have issues that are, and we've seen this as recently as Okta, where, boy, companies can turn a small issue into a much more substantial issue of trust when they decide to minimize it. It's like, it's not we want to explain to you what your exposure is or what we know the exposure to be. And then it's on all of us together to figure out what the actual impact of that is. I think it's really dangerous to say, like, oh, there's this problem, but you don't need to worry about it. It's like, why don't you tell me more information?
Especially when we've been so explicit about the problem.
Right. Well, because I think that honestly, the most important thing here, in many regards, is in terms of delivering a trustworthy system for the long term, is the trust that we have in one another, that companies have in us, that we have in our partners, and that you do not want to sacrifice that trust because of a single defect or vulnerability.
Yeah, absolutely.
So, Laura, you wrote this terrific blog entry, which came out like a week and a half ago.
Was it really only a week and a half ago?
I think that's right. Yeah, it's the 23rd of March. It is. Yeah, I mean, it's like, I guess, coming up on 2 weeks ago, but it's like, yeah, I mean, it was not that long ago. Yeah. So what has happened? Well, actually, so one thing I thought was interesting is on the first vulnerability, you wrote a terrific blog entry, and I think it was, it was technically very dense and a little underappreciated by my view is like, hey, hacker news. This is true hacker news for hackers. But that story, I think it was a little slower. I feel with this one, it really took off and people saw the significance of it right away. Is that a fair characterization, Laura?
I don't pay attention to hacker news. I have plenty.
Well done.
Oh, God, I know. I'm so sorry. I feel so dirty now. Yeah, no, I know.
Honestly, anyone out there, if you want to snipe Brian, I can give you an itemized list of ways to snipe.
Right. Turn to the page of Forbes.
Oh,
right?
God. Look, I'm immunocompromised. We know this. It's just like, yes, the list is long. I know this is sport.
We talk about vulnerabilities in software, but we have vulnerability.
That's right. This is our greatest security problem.
Look, I'm all attack surface. Okay, I'm sorry. It's true. God, it's true. But I thought it was. What's important to me that I think that this is something we should be talking about as an industry. I think it is incredibly technically interesting, but it's also very important, and it hits on these other bigger issues around how we kind of carry ourselves as companies and as consumers of technology, making technology. So yeah, I know I'm putting the best possible sheen on it, but I think it is important that Hacker News discuss this stuff. And on this, it's like people really jumped at it and discussing it in all the right ways. Of course, there were people who are asking us like, why are we still using this part? But I thought we did by and large, I thought that the tone of the discussion was exactly what you'd want, which is people both appreciating the sophistication in terms of finding this, but then especially kind of calling on folks to do better and make this stuff transparent. So Laura doesn't have to use Ghidra to figure this stuff out.
One of the things I appreciate about that discussion was the fact that this ROM had been reviewed, and Laura mentioned that in the blog post, that like alleged security experts had looked at the code, like the actual code, not through Ghidra, but like looked at it and blessed it as okay. And there's this whole industry of, patting each other on the back for these security reviews where it seems like they're paid for the answer to be yes, but that may be overly cynical.
I think it is kind of overly cynical there.
Fair enough.
I do think it is. Security reviews are a practice, but I think it's also a matter of question about what exactly are they looking for and trying to find. And I mean, no security, as I mentioned in the blog post, no security review is guaranteed to find every type of issue. But I think if we think about transparency, I think it's worth highlighting to would say, what exactly did your security review find? Because if you did a security review and the feedback is only, check plus, A plus, that's a sign that maybe it wasn't actually covering the right areas.
That's a great point, Laura, because it's like no CVEs. It's like, well, there might be two reasons for that. Either it's the most secure thing in the world, or you're lying. And same thing. Like if the report card comes back, straight A's, no problems, never missed a day in class, like that's probably not true. And if you're not willing, sure, you may not be willing to release the source code, but why not release the problems that you've already fixed? Like that seems like maybe a good first step, even in terms of the transparency we'd like to see.
Yeah, absolutely. And I love that question. What did the review find? So I know some folks have requested to speak. So I want to get, if folks have got questions for Laura or comments on other secure microcontrollers, get kind of folks, because this is, again, a very interesting issue. And so, Laura, what is the how does this? Like I said, a week and a half ago, we got this out there. What has been the reception? The non-Hacker News reception? Have folks reached out to us with superlative alternatives, or?
I haven't heard any, super exciting alternatives. I mean, I think a lot of people thought it was very interesting, and I think there's also, I think a lot of, lamenting about how this is putting something like this together is very hard in terms of making a processor, and especially trying to do security response is hard. So
it is really, really hard. It is really hard. It's very technically hard. So it is a challenge, but I think we can do better, and I would like to believe that with the transparency from these vendors, we can do better. So, Ian, did you have a comment or question?
Just thanks again to Laura for the write-up and for her the time today discussing the kind of lead up to it for both bugs. It was a very interesting discussion. I'm curious, as you were talking about the LPC55 part and the lack of documentation being a barrier to entry for you to be able to implement the things that you want to do with this part. I'm curious whether or not you're building your own internal and or personal documentation for this part as you're working your way through these questions that you have for how to implement stuff in it. And if so, is that documentation something you're considering open sourcing for other people to be able to, build upon the work you've done so far and understanding it?
I think we are working to try and I think more than anything, some level of documentation, but also especially trying to get out our own tooling to be able to do this out, which I think more than anything is a good example about how you're actually supposed to be able to do things. And I think a shining example about the other people to do or the solo keys is another example about people who want to follow. They're making security keys also based on the LPC55, and they also have their own reference code. So I think getting more reference code out there is great. And I think also just being able to try and find the community about being able to ask questions about how this works. And I mean, that's half the reason I wanted to do the blog post, is talking about how some of this actually works, so that it's hopefully out there to be able to do this. But I think if there are specific questions people have, I mean, I think we can try and figure out if there's a good way to be able to put that out there.
Yeah, CV uses documentation. I love it. And then, Laura, just so folks know, where is our kind of reference code for the tooling and the use of the LPC55?
It's on GitHub. It's on the Oxide GitHub right now. I should. A lot of it probably needs to be cleaned up and refactored in terms of that for long term. But I mean, it's certainly out there, and being able to show how some of it works in terms of being able to build these images and other things like that. And I think we have another way to go to be able to make it for what we want to do for the final product. But
I think, well, that highlights two things. One, I think it's important. Sometimes people want to wait until source code is perfect to open it, and that's really too late because it's not going to be perfect. So I think it's great that the tooling that we've got there is all out there. And then the second thing that it highlights, which is actually important, and this is not true for all of our partners, the information that we have about the way the LPC55 works is not under NDA documentation in general, or actually I put an asterisk on that. I don't think we've got, I think most of the docs that we've got are the public docs, which is maybe some exception to that. But broadly, the way the chip works is actually documented, which is not true for, say, the host CPUs, for your AMD Intel CPUs. You don't have that complete public documentation.
Yeah, and I mean, I think the documentation generally is available, and you're able to use. I mean, we're certainly not going to be out there rehosting NXP's documentation, but I think describing exactly the format of images and showing exactly how to build things out there. And I would also say, to NXP's credit, they've also gotten better. They have their own GitHub with which has their code to be able to build images and other things out there to get a better idea about how things work. And I think seeing more of that out there is great. And I think, again, that's the future we want to see.
Absolutely, steps in the right direction. And Ian, that's a great question. And I think you're going to see that for other parts that we, in particular AMD Milan, where we've taken a very, very different approach to the software out there. I do think that there'll be bits for which our source code will serve as that kind of missing documentation, where we've kind of figured out how this thing works. Todd, did you have a question for Laura?
Oh, nope. I preemptively requested.
just getting ahead of things. Just never know. It's like, or maybe you want to fight me over Jack in the Box, but I will welcome all comments.
No, it just takes time to get the mic. So I thought
there you go. That's it. Get ahead of things. And Jason, did you have a specific question for Laura?
Well, I just when you made the comment about the security by obscurity, it just reminded me of a statement I'd had heard from a company that shall remain nameless when they defined open source as permitting select partners being able to view the source code to their product under NDA.
That's their definition of open source.
Yes, and
you're like, okay.
And just when he said that, it just reminded me of that, and so I thought
Well, so one thing that actually I do find very frustrating that I would maybe we can get Rick up here to offer some color on, but this idea that you hear this excuse that like no, we can't open source our source code because then we will get dinged for our common criteria evaluation. I would love to know how true that is, because I mean, Laura, am I making that up? We have heard that from folks before.
We have heard that, and I think from some discussion with other people is that it turns out okay, I should, saying this on a recorded call and something I don't fully understand is probably a bad idea, but my understanding is that like there are a certain number of points you can assign, and I think there's some interpretation where if you have things open source, it doesn't get you full points because of the way things are, but that doesn't mean you can't meet the criteria.
Got it. So they get points off for being open source, which is that is a regulatory tragedy. I'm not sure how plausible that is to change, but
that's ridiculous. Yeah, geez.
And because unfortunately, it's like these vendors, as we know, like they need all the coaxing. It's like their disposition is already to not make this stuff open. They need all the coaxing that they can get. So just to have giving them any excuse to not make it open is really, really frustrating. And because Laura, we even offered we just want to look at the boot ROM, even under, we're certainly not asking for it to be open source. Happy to look at it. We would like it to be open source, obviously, but we're happy to look at it under even in a clean room effectively. And even that was no good.
Yeah, and I think that was rejected. And I think one of our other colleagues, Ben Stoltz, actually mentioned is that he had actually done that for other of his past work. Is exactly he had done, NDA review of boot ROM source code. I think sitting in a room somewhere. So I mean, it's certainly plausible, but again, it's you have to be allowed to be able to do that.
That's right. You have to be allowed to do that. But and certainly, I just feel that with this in particular, just feels like. If you see the source code, this one is going to be rectifiable by looking at the source code. Laura, do you want to see the source code to the boot ROM? Does this make you want to look at the source code more?
Yes, I think I do actually want to see it at this point, just to try and cross-check some other things to see if I actually got things right from my own disassembly and trying to figure out what things are doing. And
it should be said that Laura now NXP knows Laura. It's not just Oxide, but NXP is definitely whenever they please give thank Laura for her disclosure. They definitely I don't know if Laura might go so far as to say they're afraid of you, but I think they might be afraid of you.
You think they're on their Christmas card list? I mean.
I just think that they know that I do wonder if they're going to be holding their breath around the solstice. Todd, yeah, you got your hands up, and then to Ben.
Oh yeah, I guess I did have a question about just security reviews in general. As someone who runs a package manager project, how do you scale this stuff? I can understand reviewing for a particular product, but if you're accepting contributions from, say you take 500 pull requests a month or something like that. And it's for, upstream stuff. Do you have any recommendations for how to secure that or what the good practices are?
That's a great question. Laura, you want to take a swing at that one?
I think as far as scaling, sometimes I think it's just helpful to know exactly your domain area to begin with. I think in terms of trying to figure out exactly what you're trying to accomplish. And I think it's also worth, considering is that if you found one bug one time, there's a good chance you'll see other things one time. As far as trying to, scale things, I think making sure everybody is up to speed about as much. And I think also improving documentation. Honestly, I think I probably have a pretty weak answer here. So I'll defer to others if they'd like to, give a more complete answer.
Yeah, I mean, it's not that I'm going to give a complete answer because I think it's a very thorny question. I do feel, Todd, that not to be on brand, but it's much harder to review code in memory unsafe languages and be as certain. Certainly for me, the vulnerability that was found in dtrace, which was an integer overflow issue that led to a memory unsafety issue, that was lit in lint clean code, I found to be very chilling. This is code that I had reviewed, I had written carefully, it had been reviewed carefully. It wasn't sloppy, and it was clean code, well commented, and that was very chilling to me about just how hard it is to review your way into a secure system. So I think that the reviews are necessary, but definitely insufficient. And I do think you need to look at things like programming language. And then, of course, not all code touches the same part of the system. Not all code, the boot ROM in a secure microcontroller is very, very different than, a humility debugging command, for example, that where we're not nearly as worried about that kind of stuff. So I think having that kind of understanding that spectrum is important too.
I don't think I have any hopeful thoughts here other than saying, this is the problem of our era, right? That we're all including in our products any random piece of trash we find on GitHub and the transitive closure of that. And so
or in my product, in my package manager, you're including that code too. It's awesome.
Yeah. Oh, well, pardon me. Any random piece of excellence or any random piece of trash. Pardon me. I just mean we're pulling in, who knows what into our products. And how can we possibly attest to the perfection of all of it, or even that it hasn't been tampered with, unbeknownst to us. I mean,
So-
it seems intractable.
Well, so Adam, I kind of feel like, when people kind of criticize others for like, oh, you're just typing curl and piping it into bash. It's like, no, we're all typing curl and piping it into bash. Like, like you may not think you're doing that, but we are all downloading software off the internet and running it. Every single one of us.
Well, yeah, I never understand that because it's like you download a binary, you're basically typing curl and piping it directly to your processor. So, like, what's the difference?
Yeah.
Exactly. Ben, you had your hand up.
Yeah, one thing that impresses me is that this kind of work is in scope for us for developing our product. We're trying to serve customers who have been they're between a rock and a hard place. They either have to spend a lot of money on cloud services that they spend a lot of money for cloud services, and those companies have very deep pockets, and they are working in this problem because they need their customers' trust. They need to be able to run arbitrary workloads and have them be trustworthy. Versus, customers who take this task on themselves and are building together some stack of switches and operating systems and virtualization layers and hardware from suppliers. And a lot of this type of work is somebody else's problem. You're so bogged down trying to integrate these pieces and accommodate their quirks where, yes, they implement a standard, but everyone does it in their own way, which is an unfortunate reality of the industry. And this, that we don't have a BMC that has to implement CD-ROM drive emulation and remote USB and all that. We're making a fit for purpose appliance that will give you a trustworthy platform so you can run arbitrary workloads. And the part of the value is being able to trust that stack, which puts this work directly in scope.
Yeah, that's a very good point.
Yeah,
I think and we certainly talked to so many folks for whom the folks focused on the security of the system feel beleaguered because it's an afterthought, or it's not in scope, or it's something they know is important. But
there's no time or energy left to address them. You're just trying to get your network stack to talk to something else, Yeah. But that's part of what we're doing.
Yeah, which, as you're right. I mean, it's a luxury in a certain regard to be so focused on it. Because I do feel, Laura, part of the problem, part of the reason that this is not just a very hard technical problem around a secure MCU, like economically, it's not like people also want these MCUs, especially if you've got like, a Bitcoin wallet or something. It's like, oh, by the way, it needs to be like 3 cents. It's like, okay, well, which is more important because it's hard when it's not in scope for these folks.
Yeah, I think that's a very good point about trying to actually define a product, because I mean, in terms of actually trying to sell a general purpose microcontroller, just because ultimately this is something that's the LPC55 has security features, but it's still ultimately general purpose. And I mean, when we think about what it looks like long term, I think we've somewhat joked about what would, if we had our $1 billion, what would be designed for our own ASIC, about what we would exactly want to do for our own secure processor.
And it does feel like that's just going to be when Oxide does our own silicon. It does feel like this is going to be some of the first, in part because it is in scope, and as you say, Matt, your hand was up.
Yeah, so part of me is just wondering, how big is this boot ROM? Because I mean, it seems to me like the proper size for a boot ROM ought to be about 512 bytes and not much more than that. But clearly there's enough stuff in there that you're able to get all sorts of interesting bugs and behaviors. So I guess on the small, just generically, what is the ROM doing? If it turns out to be kind of, start with the first one.
So the ROM itself is definitely more than a couple of kilobytes. I mean, it contains an entire stack for parsing X509 certificates. So that should give you some of the idea about the size of this ROM and in terms of its full featured. But again, this is sort of ends up being a trade-off about what exactly it tries to do, just because I think part of the explanation NXP gave for some of this is that it turns out customers were actually asking for a lot of these things to be in ROM, especially for things like being able to write to the flash. Because the flip side about having things as ROM is that you don't have to take up your own precious flash space to be able to write things like flash loading or update mechanisms. So that good stuff, just because flash is often a limiting factor for some of these things. So I think there can be good reasons why it's there, but you have the trade-off about making sure then it starts to grow too much, and again you end up with all sorts of unknown things.
Yeah, that's a real tension. You're like, oh, well, the boot ROM has nothing in it. It's like, okay, well, now your software, and Laura, you mentioned this earlier about that you do end up in this bootstrapping problem of secure upgrade becomes really difficult without having some root of trust.
Yeah, and I think we're trying to get that in there and making sure things are out there. And again, I started out by talking about I was bricking all these trips, and I think part of the reason for having a boot ROM is that ensure that there's always something that can go up and have some way to recover the chip. So if you flash something on there in some way that's in a very wedged state, you can still manage to get in there, even if your code is very bad.
Yeah. And so, Matt, did you have a thought? Sorry, go ahead.
Well, yeah, I mean, the follow-up, if it turned out to be small, was do you think there's even any source code, or is it just some guy who's writing hand-tuned assembly? Clearly, that's not the case for X509.
No, I absolutely. I think at one point you could have argued that some boot ROMs would have just been hand-tuned assembly, but I think this absolutely looks like it is a C code that is written into there. I mean, otherwise, someone is out there writing memcopy by hand. I mean, that's certainly possible, but
yeah, and the counterpoint on the large-scale side is if you have written a software project of that magnitude with no intention of ever releasing it, I mean, do you think it's just possible that they're in a point legally where they cannot release the code, even no matter how much they want to?
Definitely possible. I mean, I don't know about the boot ROM, but you see this. I mean, I don't know, Laura. Maybe with the boot ROM we would think this as well. But there's definitely in larger. I mean, as soon as you get like off of MCUs and into like real CPU, like host CPUs that where you got hundreds of watts, there's plenty of low-level software that is being provided by other vendors, the other IP vendors, and yeah, you can't always open it. So that is a very real problem, unfortunately.
Yeah, I mean, I'd say that's a possibility, but I mean, I think there are certainly a lot of motivations for why a company might not choose to open source something, and I think this goes to a lot of just general open source philosophy, I think in general, which isn't necessarily restricted to the boot ROM. I mean, maybe they're concerned about what's actually in the code, either maybe legally, although I wouldn't want to speculate there. But I mean, sometimes it's just that they don't want to risk it, just because I mean, I think especially is that if you've ever talked to a lawyer, their job is to try and get to minimize your risk, and it turns out in looking at that from a certain perspective, not opening the code does do possibly reduces risk in that manner. Certainly I'm not a lawyer and what to do that, but I mean, I think you often find times that taking the conservative approach is what's recommended, simply because it reduces the risk. Although as we've mentioned before, that's reducing the risk can come up with other kinds of trade-offs. So
that's right. Yeah, and certainly. There's so many people that kind of claim to represent legal opinions among software engineers. Like, is this actually from a lawyer, or is this what you might? Are we playing pretend lawyer right now? And like, look, we've all done it. I played pretend lawyer, but Jason, you got your hand up. I think maybe then we'll wrap it up.
Well, I was just going to ask then, since you mentioned the X509 parsing, is that going to be the next area you look for vulnerabilities?
I have actually looked at that a little bit, and I think that's a pretty big area to try and figure out. And I mean, I wanted to try and write an X509 fuzzer, but I don't quite have the time or expertise to be able to try and do that. So
I hope NXP listened all the way to the end of the space. They're going to be someone in there is going to be replay it at the end. It's like
It's like, that's right, Dave. She's coming for you next.
That's right.
I can only imagine the amount of shenanigans that you can get up to with X509 certificate parsing on every microcontroller in the world. Clearly, Laura's plot to take over the world is succeeding.
Oh, it's absolutely succeeding. It's absolutely succeeding. All right, so here, Evan, I'm going to allow you to speak, and then I think I do want to be respectful. Laura's on the East Coast, and it's getting late over there. So, Evan, did you have a question for Laura?
Don't want to build your own X509 parser. There are a lot of good fuzzing corpus out there, and if you just shove every mutated X509 file out there, you might find something.
Evan, could you hold that thought until mid-December, please? The winter solstice is not going to come this early this year.
Sorry, Brian, the cat's out of the bag.
There you go. And did you have another question at all, or as well? That's definitely a good suggestion for when we want to discover yet another vulnerability. We're going to run out, Laura. At some point, you're going to run out of like blog titles.
I mean, I have a couple of rejected blog titles out there. I can certainly put back, but I mean, I would honestly prefer not to find any more vulnerabilities in terms of, because it's really difficult to try and ship a product when we keep finding vulnerabilities.
It is, and that's as good a note as any to end on. Laura, thank you very much. This is such impressive technical work. I mean, it was the previous vulnerability was remarkable. I thought you did just incredible work on this. It was a lot of fun to be a part of. Of course, it's easy to say that now because we know we're not vulnerable, so I'm not sure. But just terrific work here, and I think over and over again through this process, you have been a model for how we want folks to carry themselves with respect to security disposition and vulnerability and responsible disclosure and everything else. So kudos to you. Definitely inspiring to be your colleague, and thank you so much for joining us today to discuss it.
Yeah, thanks for having me. And once again, thank you for Oxide for supporting me in being able to do this type of work and, both being able to take it seriously and also support the creativity and occasionally harebrained ideas we come up with. So
absolutely. As Ben says, very much in scope. All right. Thanks so much, everyone. Hey, a quick plug for next week. We know we're due an update. We're going to have the hardware team back. We're going to be doing Tales from the Bring Up Lab. We are going to be doing talking about how our the rest of Bring Up of our EBT of the Gimlet sled, and then we're also going to be talking Bring Up of Sidecar. So should be a lot of fun, and we want to get the hardware team around the campfire before we forget some of these traumatic stories. So look forward to having folks next week. All right, take care, everyone. Thanks.
Thanks, everyone.